Okay, we are looking at inequalities and we're going to focus on three subtopics. First of all, we're going to look at numberline representation. Secondly, we're going to look at solving inequalities, so finding certain values for x, which would satisfy this kind of inequality equation. And thirdly, we're going to look at graphs and how we can represent inequalities as regions on graphs. So let's start off with the numberline representation. So I've got a simple example here, and well, first of all, I'm going to draw my number line out. So I'll put 0 in the middle. We're going to have 4 up the top and -3 down the bottom. And one way to remember how we actually draw these inequalities is this inequality here, the greater than or equal to inequality, takes much longer to say than just that inequality, just the greater than inequality. And so when I've got this extra line beneath my inequality, because it takes me longer to say, I know it's going to take me longer to draw that circle. And so I have to draw the circle and fill it in. And that's a quick cheat way of remembering which inequality is which. So just this inequality here, because it takes me a very short amount of time to say, it just takes me half a second to say, less than, I know that it's only going to take me half a second to draw that circle. So that is our inequality. Simple as that. Hardest thing is just knowing if we're doing a filled-in circle or an empty circle. And it's just if it takes longer to say or shorter to say. Let's go on to solving inequalities. So this is almost exactly the same as just solving regular equations. So we want to get x on its own. So first of all, I'm going to add 2x to both sides. We're going to end up with 14 is greater than or equal to 8 plus 2x. Let's get rid of this 8 now. So I'm going to subtract 8 from both sides. We're going to end up with 6 is greater than or equal to 2x. And finally, we're going to divide both sides by 2. So 3 is greater than or equal to x. Or we could think of this as x is less than or equal to 3. Either one is correct. There's one caveat to this. So there's one kind of trap that people often fall into. So I'm gonna copy this out down here, and I'm gonna show you first of all what the trap is, and then how we can avoid it. So if we start off at the beginning again, this time I'm not going to do the same method. I'm going to do a slightly different method. So I'm going to decide to have all my x's on the left-hand side rather than on the right-hand side. In that case, I'm going to subtract 14 from both sides. So I'm going to end up with 2x is greater than or equal to -6. And then I'm going to divide both sides by 2. So -x is greater than or equal to -3. And finally, I'm going to times both sides by -1, or divide both sides by -1. Either way is the exact same. The effect that it has is obviously just to cancel those minuses out, because minus minus gives us a plus. And we get x is greater than or equal to 3. Well, we can see instantly that these two solutions are not the same, right? We can't have x is less than or equal to 3 and x is greater than or equal to 3. And so we know we've slipped up somewhere. And the mistake that we've made, the trap that we've fallen into, is when we times by -1, we have to remember to flip this sign around. And so whenever we times by a negative number, we always flip the sign around, and that allows the inequality to stay true. So once we do that flip, we can see again we end up with the exact same inequality. I've just realized I've not flipped the sign. I've just kept the sign where it is. We flip the sign and we end up with that same inequality. So we can see those two are the same. Right, finally we'll look at subtopic number 3, graphs. So this is a way of kind of graphically representing an inequality. So I'm using the same example as in the first subtopic in number lines. So this time we're going to actually put it onto a graph, so an XY graph. So we've got X here and Y here. And we're told that X is less than 4. So I've got 4 here, and X is greater than or equal to -3. So I'm going to have -3 down here. So it's very similar to the Numberline version. Well, I know that when I've got my Numberline version, greater than or equals to means I have a filled-in circle. And just like that, very similar to that, I have a filled-in line that goes through my -3. Well, because X is less than 4, just like my empty or my kind of half circle, I've got a dotted line or a line with half of itself missing. And that inner region between these two lines is going to represent the valid region where X will be true for this inequality. Right, let's go ahead and do some example questions. So we've got 3 questions, 1 for each topic. So first of all, we're going to look at showing an inequality on a number line. So we've got an inequality, X is greater than -3. Well, because greater than doesn't take us very long to say, we know it's going to be an empty circle, right? It doesn't take us long to draw the circle. If this was greater than or equal to, we know it would take us longer to draw the circle, and therefore we would fill in that circle. This is slightly different to what we did in the first example, right? Because we don't have this, a second bit. We don't have anything here. And so what we do in that situation is we just draw an arrow. So I know that X is greater than -3. So anything above -3 is going to be valid for this inequality. Right, question B. Solve the inequality of 7y minus 34 is less than or equal to 8. And so just like with a regular equation, I can rearrange this. I can add 34 to both sides. And so I get 7y is less than or equal to 42. And we're going to be testing our 7 times tables. We can divide both sides by 7, and we end up with y is less than or equal to 6. And so that's my final answer. Finally, we want to look at shading regions to represent inequalities. And in this instance, we've got 3 different inequalities. And so first of all, we've got y is greater than -4. Well, -4 is down here. I'm looking at the y variable, so I know I'm going to be concerned with blocking off a full region either above or below -4. And so anything above -4 is going to satisfy that inequality. Next up, we've got x is less than 2, and so I'm going to be blocking off a horizontal region. And so anything above this line and anything to the left of this line is at the moment going to satisfy these 2 inequalities. Finally, y is less than 2x plus 1. Well, if we imagine drawing a line of y equals 2x plus 1, it's going to make this much easier to understand, right? So if I just plot y equals 2x plus 1, well, I know it intersects at 1, right? I've got kind of y equals mx plus c, right? And therefore that 1 is going to be my y-intercept. So it goes through 1, and it's got a gradient of 2. And so if I go along 1, I have to go up 2. I go along 1, I go up 2. And I go down, I go kind of back 1, and I go down 2. And we start to build up our straight line for that equation. We end up with a line that looks a little bit like this. Well, we're told that y doesn't equal this line. Y has to be less than this line. And so anything below this line is, again, going to be valid. And so what we're left with is this small region between these lines, where it's to the left of this vertical line, it's above this horizontal line, and it's below this diagonal line. And that's how we can represent inequalities as regions. And that brings to a close inequalities.